Now we'll consider another waveform generator, that is a square wave generator, or more theoretically it can be referred to as, of course, it is a square wave generator, and always a square wave generator, or in almost all cases a square wave generator will be a sawtooth generator also in some nodes of the circuit. More theoretically it can be referred to as an astable multivibrator. An astable multivibrator is a multivibrator or a waveform generator having two different quasi-stable states. So it has two different partially stable states. As long as the opamp is concerned, these partially stable states are plus V saturation and minus V saturation. So the output will be coming to one of the quasi-stable state, stay there for a particular duration, then the output will be switching to the other quasi-stable state, stay there for the duration for which it was there in the other quasi-stable state, so that in the output you will be getting a square wave. So this can be referred to as a square wave generator as well. This square wave generation will be most often at the expenditure of the charging and discharging of a capacitor that always produces a waveform which is sawtooth in nature. How the sawtooth waveform is produced here, how a square wave is produced in the output, we will look into it now. So for the circuit, you have a positive feedback employed with the help of the resistances, say R1 and R2. The part of the output energy appearing across R2 is injected to the non-inverting terminal. So it's a positive feedback, and the feedback fraction is R2 divided by R1 plus R2. And in the inverting terminal, a capacitor is being placed and is connected to the output voltage through a resistance R. So if the experimental conditions are suitable, the output voltage will cause a charging of the capacitor C through this resistance R, and under suitable experimental condition, the charged capacitor can discharge through this resistance R to the output voltage point and ground. So there is a scope for the capacitor to charge and discharge continuously depending upon the status of the output voltage. Now let's consider the working. This is somewhat non-readable. Anyway, I'll tell you. You can listen carefully. We assume that the moment we switch on the circuit, some kind of an error voltage will be there between the two input terminals of the op-amp, and the output, depending upon the polarity of this error voltage, will be switching into either plus V saturation or minus V saturation. To have a go, let me take this output voltage is at plus V saturation the moment I switch on this circuit. So the output is at plus V saturation, and if you are interested in digits, let me take this value as say 10, and let me take R1 and R2 are exactly equal, so that feedback fraction is 1 by 2. Then the voltage at the non-inverting terminal will be modified as V saturation into R2 divided by R1 plus R2, that is beta V saturation. Since the output is at plus V saturation, the voltage clamped here will be plus beta V saturation, plus beta V sat. And this V sat is 10 and beta is half, then this voltage is assumed to be say 5 volt. And at the same time, this voltage can cause the charging of the capacitor through this resistance R. Since this voltage can appear V saturation, the output voltage can appear across R, and no current will be flowing through this path, so that the only way it can go to the ground terminal is by charging the capacitor. So the capacitor will start charging from 0, and the plate voltage of the upper plate of the capacitor start increasing, and it is this voltage that is being given to the inverting terminal of the op-amp. So the voltage becomes 0 volt, 1 volt, 2 volt, 3 volt, etc., etc. And on the course of each and every moment or instant of charging of the capacitor, the voltage injected to the inverting terminal increases. And at every instant, the op-amp will be making a comparison of the two input voltages given to the two input terminals of the op-amp. The non-inverting terminal now has a voltage 5. The inverting terminal has a voltage 0. Make a comparison. It is 5. It is 0. High voltage is given to the non-inverting terminal so that the comparator output will be at plus V saturation. It becomes 1 volt. Then also high voltage is given to the non-inverting terminal. Output will be at plus V saturation. It becomes 2, 3, 4, 5 and the very next moment this voltage becomes 5.0001. At that instant, the voltage given to the inverting terminal exceeds that given to the non-inverting terminal, so that the comparator output will sharply and suddenly switch into minus V saturation. So, the capacitor can charge from 0 up to plus beta V saturation. When the capacitor voltage becomes plus beta V saturation and try to increase beyond it, the output will be switching from plus V saturation to minus V saturation. So the output will be at plus V saturation till the capacitor plate charges to a voltage, say, plus beta V saturation. At the moment it starts or try to increase beyond plus beta V saturation, output will be switching into minus V saturation. So the voltage here becomes minus V saturation, that is say minus 10 volt. Then all the stories take a reverse turn. When this voltage is negative, beta V saturation also will have a negative polarity. So this becomes say minus 5. And the capacitor have been charging from plus V saturation. It can charge up to plus beta V saturation. When it becomes beta V saturation, this voltage suddenly take a reversal. This becomes minus. So the capacitor place has a voltage plus 5 and this is minus 10. Then the capacitor will be discharging through this path to normalize minus V saturation. Then the plate voltage of the capacitor will be falling from beta V saturation to 0. Say 5 becomes 4, 3, 2, 1, 0. And all those instances the op-amp will be functioning as a comparator. It will be going on making this comparison. When this becomes say 4 volt, the comparison will be like this. This is 4, this is minus 5, 4 is greater, output will be at minus V saturation. When this becomes 0, this is 0, this is minus 5. Inverting voltage, inverting terminal has a greater polarity, output will be at minus V saturation. Then the capacitor will be charging in the reverse manner. It charges to minus 1 volt, minus 2 volt, minus 3 volt. All these voltages are greater than minus 5 because when the number is negative, smaller number will be taken as the smaller number with smaller magnitude will be taken as the larger number, or it is the larger number, as you know. So this becomes a minus 5. And at the very next moment it will try to charge to a more negative voltage, minus 5.0001. And at the very instant this polarity, the voltage given to the inverting terminal is found to be less than the voltage given to the non-inverting terminal. Then the output will be switching into plus V saturation. Then all of the stories changes. Here this voltage becomes plus beta V saturation, that is plus 5. Capacitor has a voltage minus beta V saturation and the voltage at the output is now plus V saturation. It will force the capacitor to charge from minus beta V saturation to plus beta V saturation. So in a cycle, capacitor can charge from minus beta V saturation to plus beta V saturation. And corresponding to that, the output will be staying at plus V saturation when the capacitor plate charges up to plus beta V saturation. The moment the capacitor plate has a voltage exceeding plus beta V saturation, output will be switching from plus V saturation to minus V saturation. Now the output will stay at minus V saturation till the capacitor plate discharges to say minus beta V saturation. And when the capacitor plate has a charge exceeding in magnitude minus beta V saturation, output will be switching back to plus V saturation. So continuously you will be getting a waveform like this. The duration of this higher pulse is the duration by which capacitor is charging from minus beta V saturation to plus beta V saturation. And the duration of this pulse, lower pulse or TL, is the duration taken by the capacitor to discharge from beta V saturation to minus beta V saturation. So the time taken for this pulse and this pulse, lower pulse and higher pulse, are exactly equal, so that the waveform will be a square waveform. And if you are recording the capacitor plate voltage, it will be a sawtooth waveform like this, with the voltage values from minus beta V saturation to plus beta V saturation. So simultaneously it can function as a sawtooth generator, or rather a triangular waveform generator, since the rise time and fall time are exactly equal, and a square wave generator. Now we will work on the period and frequency of this vibrator. Yeah, the capacity. So the duration of TH and TL are exactly equal, as I have already told you. So either you can calculate TH or TL and take the double of this, so that you will get T as TH plus TL equal to T. Then for TH, the output will be at plus V saturation when the capacitor charges from minus beta V saturation to plus beta V saturation, when the output is at plus V saturation. Then the charging equation of the capacitor can be written as capacitor charge ചെയ്യാവുന്നത് plus beta V saturation വരെ ആണ്. അന്നേരം capacitor ചാർജ് ചെയ്യാൻ കൊടുത്തേക്കുന്ന വോൾട്ടേജ് V saturation ആണ്, Vsat ആണ്. അപ്പോൾ Vsat എന്ന വോൾട്ടേജ് വെച്ചിട്ടാണ് ഇപ്പം ചാർജ് ചെയ്തുകൊണ്ടിരിക്കുന്നത്. പ്ലസ് ബീറ്റ V saturation വരെ ചാർജ് ചെയ്യാം. അപ്പോൾ ചാർജിങ് ഇക്വേഷൻ V saturation ഇൻറ്റു 1 മൈനസ്, പക്ഷേ കപ്പാസിറ്റർ 0 തൊട്ടല്ല ചാർജ് ചെയ്യുന്നത്, മൈനസ് ബീറ്റ V saturation എന്നുള്ള വോൾട്ടേജ് തൊട്ടാണ്. അപ്പോൾ ഓൾറെഡി അതിൽ ബീറ്റ V saturation എന്നുള്ള വോൾട്ടേജ് എക്സസ് ആയി കിടപ്പുണ്ട്. അപ്പോൾ ഇവിടെ 1 പ്ലസ് ബീറ്റ എന്നുള്ള ടേം എഴുതണം എക്സ്പോണൻഷ്യലിന്റെ കോയിഫിഷ്യന്റ് ആയിട്ട്. ദിസ് തിയറി ഐ ഹോപ്പ് യു മൈറ്റ് ഹാവ് ഡിസ്കസ്ഡ് ഇൻ യുവർ ഡിഗ്രി ക്ലാസ്സസ് while you talked about network theorems. So 1 plus beta e raised to minus t divided by RC, where RC is this time constant. Now V saturation vanishes. You can take beta to the right side and this negative term to the left side to make it say 1 plus beta into e raised to minus t by RC equal to 1 is already there on the right side. Take beta to the right side to make it say 1 minus beta, or 1 plus beta can be taken to the right side. E raised to minus t by RC then becomes 1 minus beta by 1 plus beta. You take the reciprocal on both sides, then this becomes e raised to t by RC, where t is equal to th equal to TL. So either you can put th here or TL here or t here. Then e raised to t by RC equal to e raised to minus t by RC and 1 minus beta by 1 plus beta. So e raised to t by RC 1 plus beta by 1 minus beta ആയിരിക്കും. 1 plus beta by 1 minus beta. Now take the natural logarithm, then this becomes t by RC equal to natural log 1 plus beta by 1 minus beta. So that t equal to RC natural log 1 plus beta by 1 minus beta. So that period t equal to th plus TL equal to or 2t, if you are putting it as a small t only, then period equal to 2RC natural log 1 plus beta by 1 minus beta. So this is the expression for the period. Once you have the expression for the period, frequency is reciprocal of the period. And often we take R1 and R2 as equal, so that beta will be equal to half. then this is 1 plus half, 3 by 2, by 1 minus half, 1 by 2. 2 vanishes, the bracket becomes 3. Then natural log 3 is 1.1, so this is approximately 2.